manner, you can use the subsystems to encapsulate and hide internal audio processing pipeline, protecting the proprietary DSP algorithms and intellectual property, while exposing only well-defined interface to the end user. Here we have created example layout, which we want to create hide to the partners. So what we can do, we can use the subsystem. So to create subsystem, simply remove this wire which is connected to the input, and as well as the which is connected to the output. So you need not to completely capture into subsystem. You can use any number of the modules as whatever you want to basically hide. In the module palette called common, there is a module called subsystem mono input and also subsystem mono output. Drag these two modules, keep the input here. Okay, connect this to your starting module of your audio pipeline, and then wherever you want to finish your subsystem, keep this subsystem output. Okay, so you can keep the outputs, just leave them as it is, need not to worry. And then if you want to create a subsystem with the multiple input, multiple outputs, simply drag more subsystem input and output modules, and then all will be encapsulated into a single module. Once you finish this, simply click on the button here called generate subsystem. What it does, it actually generates the 3 files. Every module will have a XML and C file, and as well as the header file. It will generate those files into a folder. So you can select that into the modules. So in the AMI designer, we package like modules. In the modules, so there is a folder called subsystem. Simply select this and then say OK. See, it generated the 3 files as I mentioned here. So it generates the name will be whatever the name that you kept for the subsystem. So here .c file, .h file, .xml file. Okay, by this it's actually generated the completely done the subsystem creation. Now simply come here, close this if you want to. Okay, save as, that's fine. Okay, and then now come here and rescan the modules. Okay, it will scans all the modules that along with the whatever now it is created. Go to the subsystem. We already have 2 examples. Now this is what we actually generated. Simply drag and drop here into the layout, and if you double click on it, no module inspector, it doesn't have any parameters not populated. So what we can do, we can group the different modules parameters in a single inspector here, and then do that. So basically what we need to go, open the XML file wherever it is generated. So as of now we have generated here in the subsystems modules, fract subsystems. Go here into the XML. There will be XML related to this subsystem. This is the subsystem XML. Open this. Okay, so you can see all the modules related to the in the layout. You can see it here, all the modules. So suppose you want to take the level of the speaker level. So if you look at these 2 variables, this is the speaker level, is the render variable of the module. This one, speaker level amplitude. Okay, so these 2 are very important. If you want to set them or you want to see them on the inspector, it has to be true, design settable and tunable. When design settable means when you are in the design mode, when you click on it, it will be shown up in the inspector. When you make it as a true for the tunable, while in the tuning also you can basically change those variables. So whatever you want to make it as an inspector parameters, you can simply say true. So I am taking this variable for the design settable as well as the tunable. And also I want to take one SVF module filter type. Let's go to the SVF module. So if you turn controls and then go to the second order filter, it is there in your layout. Okay, so this is the first one. So what I'll do, I'll go to the look for the frequency. I want to design settable as well as the tunable, so I will make it as a true. I'll also make this as a true. Maybe I'll also take the gain factor of the Q also if you want to, or just gain. Okay, let me take the gain variable as well. Gain. Oh, filter type we did test true. Okay, let's make test true. This also true. Okay. frequency I kept as true, and then gain also I want to make it as a true. So these will be populated whenever you see the new module inspector. Okay, now go to the AGC. You want to also change the AGC gain. Okay, you can search AGC. Okay, so you can to AGC module. You want to change the limit, the limiter, maybe the ratio you want to see, right? So make it true. And then ticket and fine. You want to threshold also, limiter threshold also you want to see as a true, right? So make it as true. True. And maybe gain also you want to, output gain also you want to make it as visible on the inspector. So make it true. True. That's all. Save this file and then rescan from the XML. Okay, and also rescan this guy. Okay, now double connect. Now you can see all whatever we have selected. See, level we have made as a true, and then filter type also we made as a true, and then and then also limiter ratio, and then threshold and dB gain. If you look at in the original layout, these are all different modules, but using subsystem you can also map all the different modules parameters into a single inspector and then tune it eventually in the final product. Okay, yeah, so like this now we can connect to input and connect to the output, and then simply generate the code and build and run. So all your previous signal chain was encapsulated into a single module. Nobody knows what signal chain that you are using inside. The actual layout for this one is, original one is this one. All these modules were encapsulated into that single module. So end user or your partner will not see the what is in the inside, so that it will be your IPv is protected. Okay, so like this you can use the subsystems. You can create any number of the subsystems and then add into your final layout and tune it. Thank you.